Subscribe and download over 1 million code snippet including this tutorial from codegive.com, link in the description below. The normal distribution, also known as the Gaussian distribution, is a continuous probability distribution that is symmetric around its mean, representing a bell-shaped curve. In this tutorial, we'll explore how to work with the probability density function, PDF, of the normal distribution in Python, using the scipy.stats module. Make sure you have Python installed on your machine. You can download and install Python from python.org. Additionally, you'll need to install the scipy library, which includes the statistical functions we'll be using. The PDF represents the likelihood of a continuous random variable falling within a particular range. For a normal distribution, the PDF is given by the formula f x mu sigma equals 2 pi sigma 2 1 e 2 sigma 2 x mu 2, where. Now, let's implement the normal distribution PDF in Python using the scipy.stats module. In this example, run the script, and you should see a plot of the standard normal distribution PDF. Feel free to experiment with different mean and standard deviation values to observe their impact on the shape of the distribution. This tutorial provides a basic understanding of the normal distribution PDF in Python using the scipy.stats module. You can further explore statistical analyses and applications using normal distributions in your projects. ChatGPT. The normal distribution, also known as the Gaussian distribution or bell curve, is a fundamental concept in statistics and probability theory. In Python, the probability density function, PDF, of the normal distribution can be explored and visualized using various libraries. This tutorial will guide you through understanding the normal distribution PDF and provide code examples using the scipy and matplotlib libraries. Make sure you have Python installed on your system. You can install the required libraries using the probability density function, PDF, describes the likelihood of a continuous random variable taking on a particular value. For the normal distribution, the PDF is defined by the following formula. F x mu sigma equals sigma 2 pi 1 e 2 sigma 2 x mu 2, where. Let's create a Python script to generate and visualize the normal distribution PDF. This script defines a function plot_normal_distribution that takes the mean, mu, and standard deviation, sigma, as parameters, generates data points, calculates PDF values, and then plots the normal distribution using matplotlib. The example at the end of the script plots a standard normal distribution with mean equals 0 and standard deviation equals 1. Understanding the normal distribution PDF is crucial for various statistical analyses. Python, with its powerful libraries like scipy and matplotlib, makes it easy to work with and visualize probability distributions. Experiment with different mean and standard deviation values to observe how they affect the shape of the normal distribution. ChatGPT. The normal distribution, also known as the Gaussian distribution, is a continuous probability distribution that is symmetrical around its mean. The probability density function, PDF, describes the likelihood of a random variable falling within a particular range. In this tutorial, we'll explore the normal distribution PDF in Python using the scipy.stats module. Before we begin, make sure you have Python installed on your machine. You can download and install Python from python.org. Additionally, you'll need the scipy library, which you can install using The PDF of the normal distribution is given by the formula f x mu sigma equals sigma 2 pi 1 e 2 sigma 2 x mu 2, where. Now, let's create a Python script that demonstrates how to plot the normal distribution PDF using the scipy.stats.norm module. Explanation of the code. Understanding the normal distribution PDF is essential in statistics and data science. This tutorial provided a basic overview and a Python code example using the scipy.stats module. Feel free to modify the mean and standard deviation parameters to observe how they affect the shape of the distribution. ChatGPT